Tomato leaves curled, speckled with holes, fine white webbing between the stems. Flip a leaf over, tiny red dots crawling underneath. Most people reach for the nearest spray bottle, or they give up. They tell themselves the bug's already won. They're wrong. Agricultural researchers studying pre-industrial farming found something that changes everything. An infestation isn't a lost cause. It's an ecosystem out of balance, and it can be pushed back into balance with the same tools farmers used for thousands of years before pesticides existed. That reversal can start working overnight, with ingredients already in your kitchen, your shed, your backyard. 7 of them, 7 zero-cost remedies, now confirmed by modern labs, that Roman farmers, Ayurvedic growers, and generations of subsistence gardeners relied on, long before pesticide was a word. And the pest control industry left them out of the conversation for one reason. There's no patent on a garlic clove. 7 remedies, what each one does to a pest at the molecular level, and why every hour you wait is another generation of eggs hatching under those leaves. But first, the mistake that stops nearly all 7 from working at all. 1. The allium weapon. Garlic and onion infusions. What actually makes a pest leave a plant alone? Smell, or something deeper. It's deeper. Crush garlic or onion, and an enzyme, alliinase, converts alliin into allicin, which breaks down into diallyl disulfide and diallyl trisulfide. Those compounds bind directly to TRPA1, a receptor in the sensory organs of flies, mosquitoes, and crawling insects. Trigger it, and the insect doesn't just leave. It stops mating. Females stop laying eggs. Here's the mistake. Gardeners toss a few cloves near the soil, or scatter garlic granules, and expect results. It barely works. The compounds need to be extracted and concentrated to hit the pest's sensory system hard enough to matter. The real method: crush garlic into oil, steep 12 to 24 hours to stabilize the sulfur compounds before they evaporate. Strain. Mix a small amount into water with soft potash soap as a surfactant so it coats leaves instead of beating off. Lab trials on red spider mites. A 30% garlic extract achieved complete immobilization and killed eggs outright within 24 hours, matching synthetic acaricides. And wasps lack the TRPA1 receptor entirely, so this spray clears pests without touching your pollinators. Nobody can patent a garlic clove. That's a quiet reason this remedy faded from mainstream advice, even as the lab research kept confirming it works. One caution: spray only at dusk or dawn, never in direct sun, or the oil scorches leaves. Stop spraying at least 30 days before harvest. The flavor lingers. Garlic clears the threat on contact. The next remedy attacks something garlic can't touch. 2. The nightshade secret: tomato leaf decoctions. Tomato leaves are toxic, so why brew them into a spray? Because the toxicity is the point. Tomato leaves carry tomatine, a steroidal glycoalkaloid concentrated in the foliage. Harmless to you, lethal to aphids, spider mites, and young caterpillars. The mistake: gardeners assume more concentrated means faster results, so they boil it down hard and spray it on everything, including their tomatoes. Wrong move. Correct method: chop leaves and stems, steep overnight in cool water, or scald briefly for a faster extract. The glycoalkaloids leach into the liquid. Sprayed on pests. Tomatine attacks 2 ways: contact poison outside, stomach poison if ingested. It binds to sterols in the pest cell membranes, causing them to rupture. Death within hours. Non-negotiable rule: never spray this on any other nightshade. No eggplant, no peppers, no potatoes, no other tomatoes. Not because of the tomatine. Because tomato foliage can silently carry viral, bacterial, or fungal pathogens that transmit straight to a related plant, even from leaves that looked healthy. Applied right, dusk or early morning, outside the nightshade family, this clears soft-bodied pests within a day or 2, using leaves you'd normally throw away during pruning. Garlic hit the nervous system. Tomato leaf ruptures cells directly. Neither touches the pests that eat with enough force to strip a plant bare overnight. 3. The fire barrier. Capsaicinoid pepper sprays. Insects can't taste heat the way we do, so why does pepper spray stop them from feeding? Capsaicin doesn't work through taste. It penetrates the pest's lipid membranes and disrupts ion balance in its nervous tissue, full-body chemical irritation severe enough to stop aphids, thrips, and whiteflies from feeding almost instantly. The mistake: blend hot peppers with water, pour straight into a sprayer, skip straining, clogged nozzle, wasted batch. This is the single biggest reason this remedy fails. Correct method: blend about 15 whole hot peppers, cayenne or habanero, into a liter of water with a few drops of mild liquid soap. Steep 24 hours to pull the capsaicin fully into the liquid. Strain thoroughly through cheesecloth before it touches a sprayer. Applied to new growth in the evening, it creates an immediate feeding deterrent for spider mites, thrips, and caterpillars. Bonus: sprayed within 4 inches of the root zone, it also drives off gophers, moles, and squirrels. The same irritation that stops an insect is unbearable to a mammal's nose and paws. Safety note: this is a real extract, not a kitchen novelty. Gloves, eye protection. Test on 1 leaf before spraying the whole bed. Garlic hit nerves. Tomato leaf ruptured cells. Pepper spray builds a wall the pest won't cross. None of these 3 touch the fungal disease spreading across the leaves at the same time. 4. The sunlight weapon. Photodynamic milk and whey sprays. Why would milk splashed on a leaf kill a fungus that synthetic fungicides are engineered to fight? For decades, even gardeners who swore by milk spray assumed it just smothered the mildew physically. Microscopy proved otherwise. When milk proteins, lactoferrin and whey globulins, sit on a leaf and get hit by UV sunlight, they trigger a photodynamic reaction that generates reactive oxygen species, real cellular damage. The mistake: spraying in the evening, assuming darkness and moisture help it sink in overnight. Backwards. No UV, no reaction, no fungal damage, just milk sitting on a leaf, doing nothing. Correct method: a 10% solution, 1 part skim milk to 9 parts water, sprayed strictly on bright, sunny mornings. Non-negotiable. UV striking the wet residue triggers the reaction that oxidizes and ruptures the fungal cell walls within about 24 hours. Second mechanism: lactoferrin binds iron, starving fungal spores of what they need to germinate in the first place. This spray doesn't just kill active mildew, it blocks new spores from ever taking hold. Always use skim or non-fat milk. Whole milk sours fast on warm leaves and turns a fungicide into a smell problem within a day. Garlic worked on nerves. Tomato leaf ruptured cells. Pepper built a barrier. Milk uses sunlight as a weapon. None of these 4 were built for pests protected by an armored shell. 5. The ancient armor breaker. Wood ash and diatomaceous earth. How does simple powder kill an insect with a hard exoskeleton? Pure physics, no chemistry. The crystalline silica and calcium carbonate in wood ash is microscopically sharp. It abrades the thin, waxy layer coating a pest's exoskeleton, the layer locking in its moisture. Once breached, the ash pulls water straight out of the pest's body. Death by desiccation. The mistake: applying raw ash straight from the fireplace. Raw ash carries soluble potassium and sodium salts that get in the way. Trials found that washing and boiling ash before drying and reapplying cut beetle knockdown time nearly in half compared to unwashed ash. Correct method: wash raw ash in water, let it settle, dry it out before dusting soil and foliage. This strips the salts and leaves a concentrated porous silica skeleton that strips wax far more aggressively. No time to wash it? Food-grade diatomaceous earth works through the same mechanism, straight from the bag. Apply during dry stretches. Even light rain washes the barrier away. Bonus: it also disrupts the scent cues pests use to find host plants, making leaves so unpalatable that chewing insects often abandon them before taking a bite. Caution: wood ash is highly alkaline. Keep it away from acid-loving plants, and don't let it build up in one spot season after season. Garlic disrupted nerves, tomato leaf ruptured cells, pepper irritated membranes, milk used sunlight. Ash breaks the armor apart mechanically, nothing a pest can build resistance to. But none of these 5 were built for threats that live buried in the soil or drift in on the evening air as smoke. Before the mid-1900s, none of this needed explaining. Synthetic pesticides didn't exist. From Roman vineyards to Indian rice paddies to colonial American homesteads, farmers relied on plant extracts, minerals, and fermented preparations to keep pests in check. Crop protection wasn't an industry. It was an extension of caring for the ecosystem a farm depended on. Then came organophosphates and organochlorines, engineered to kill on contact, at a scale no hand-mixed garlic spray could match. Alongside the Green Revolution, it helped feed a rapidly growing global population. That's a real benefit. Worth being honest about, but there's a trade-off most gardening content skips. Synthetic compounds were engineered to resist breaking down. They persist in soil, water, and plant tissue, sometimes for decades. Because they work through one narrow chemical pathway, pests evolve resistance fast, forcing ever stronger formulas. And the same broad-spectrum toxicity that kills the target pest also kills the lady beetles, lacewings, and parasitoid wasps that would have controlled it naturally, wiping out the garden's own immune system. For someone staring at one infested tomato bed, none of that history matters. What matters? The ancient methods still work, and in documented cases, they outperform synthetic replacements at this scale. A 30% garlic extract matches synthetic acaricides against spider mites. A tomato leaf decoction clears aphids with 0 decade-long residue. None of these 7 remedies carry the resistance risk of a repeated synthetic spray, because they attack through multiple pathways at once. Not one narrow target a pest can adapt around. The industrial answer solved a global problem. It was never built for your backyard tomato plant. The old methods were. 6. The smoke and the buried vessel, Dhupana fumigation, and Kunapajala. Could burning a specific blend of household items protect an entire tree from disease? Just from the smoke. This one comes from the Vrikshayurveda, an ancient Indian agricultural tradition that treated plant health as a full ecological science millennia before modern plant pathology existed. Its technique, Dhupana, medicinal fumigation. Farmers burned cow ghee, dried herbs, mustard seeds, and turmeric in an iron container near affected trees, letting smoke settle over the foliage at dusk. For centuries, outsiders dismissed this as ritual. Modern chemical analysis says otherwise. Burning ghee releases acrolein, genuine antimicrobial, sterilizing properties. Burning milk solids alongside it triggers caramelization that releases diacetyl, a direct contact neurotoxin against spider mites, whiteflies, and aphids at high concentration. Burning honey contributes hydroxymethylfurfural with documented antifungal activity. The mistake, treating it like a bonfire. Bigger smoke, better results. Wrong. Correct method, small iron brazier, modest herbal blend, lit at dusk so the smoke settles low and slow over the orchard through the cool overnight hours. Alongside it, Kunapajala, fermented filth, a nutrient-dense liquid of animal remains, bone, blood, sesame cake, milk, and dung, sealed in buried earthenware for 10 to 30 days. That fermentation breaks proteins down into bioavailable nitrogen, phosphorus, and potassium, plus natural growth stimulants. Applied as a soil drench, it rebuilds the microbiome and triggers the plant's own resistance against pests, from the roots outward. Safety note: let the smoke cool slightly before it drifts onto foliage. Never inhale it directly during preparation. 6 remedies down: nerves, cell membranes, chemical irritation, sunlight, mechanical armor, now smoke and soil. 1 category left untouched: pests that only come out after dark. 7. The night watch. Traps, oils, and ancient sap slugs feed at night to avoid drying out in daylight. So why spray them during the day at all? This remedy skips chemistry entirely. It's timing. Slugs, snails, earwigs, and sowbugs are nocturnal by necessity. Daylight kills them through desiccation as effectively as any spray. Ancient growers built defenses around the pest's own schedule instead of fighting it. The mistake: sinking a beer trap flush with the soil, assuming smell alone works. If the rim sits above ground, pests just wander past. Correct setup: rim 1 inch below the surface, forcing pests to climb down and over the edge, where they fall in and drown, drawn by the same yeast volatiles that make beer smell appealing to us. Second method: inverted citrus rinds or flat boards laid across bare soil at evening, dark, humid pockets where slugs, earwigs, and pillbugs cluster before sunrise. Lift the board in the morning. Collect them. No spray. No residue. For tree pests, Roman agronomists developed amurca, the bitter residue from pressing olive oil. Boiled in copper vessels, it concentrates polyphenols while drawing in copper ions, creating an organocopper fungicide against bark and leaf disease. Romans went further, blending boiled amurca with cucumber juice and lupin extract into a sticky wash that trapped caterpillars on contact, and coating pruning knives in animal fat between cuts to stop pathogens spreading tree to tree. Maintenance note: beer traps lose potency as yeast volatiles fade. Empty and refill every 3 days. 7 remedies, 7 mechanisms: nerve disruption, cell rupture, chemical irritation, sunlight-triggered oxidation, mechanical desiccation, antimicrobial smoke, and behavioral trapping, timed to the pest's own clock. None of them rely on a single pathway a pest could ever evolve past. 7 remedies: garlic and onion, tomato leaf, capsaicin pepper spray, photodynamic milk, wood ash, and diatomaceous earth, Dhupana fumigation, and buried Kunapajala, nocturnal traps built from beer, citrus rinds, and ancient olive oil residue. Each one solves a different infestation. Each costs next to nothing. Each starts working within a night to a few days, not weeks. The principle underneath all 7: pests aren't defeated by one overwhelming strike. They're defeated by attacking from every angle the ecosystem allows, the same way nature keeps itself in balance. Onion peels, spoiled milk, wood ash, kitchen scraps, pruned tomato leaves. What modern gardening taught you to throw away is, in nearly every documented case, exactly what your garden needs to protect itself. The industrial chemical industry solved a global food crisis. It was never built to solve the 7 aphids on your pepper plant or the mildew creeping across your squash this week. Next time you find curled leaves, chewed holes, or a dust of mildew spreading, pause before reaching for the bottle with the warning label. The cure is probably already in your kitchen trash, your fireplace, or the shed out back. This channel exists to dig up the knowledge industry never had a reason to keep alive and hand it back to the people actually growing the food. If these 7 are just the start of what you want to know, we've put every homemade spray, ratio, and pest-specific recipe we've tested into one place: the Organic Pest Control Handbook. Step by step, no synthetic chemicals, no guesswork, just the recipes and timing that actually work. Link below. Scan the QR code on your screen to go straight there. If this taught you something today, subscribe and share it with a gardener, it'll help. The next video reveals even more. Happy gardening.